How are aircraft carriers built? In this episode, the video captain will take you on an exploration. In the early days, the runway on the deck was very short. To quickly increase the speed of takeoff, engineers installed a wooden tower catapult. When the weight at the top dropped, it directly pulled the ropes on the track, allowing the aircraft to reach takeoff speed instantly. However, over time, the deck suffered from damage due to the impacts, and engineers had to come up with a new solution. They installed steel tracks at the stern of the ship and stored compressed air in cylinders to provide thrust for the catapult. When the aircraft was ready, compressed air would be injected into the bottom cylinders, pulling the aircraft into the air. But using only compressed air couldn't provide enough force to launch aircraft weighing over 800 kilograms. To address this, engineers used a pulley system to increase the tension on the ropes by more than 7 times, allowing even heavier aircraft to take off successfully. However, the track system took up a lot of space, and returning aircraft had to land in the water and be lifted back onto the deck with winches. This severely affected maneuverability. Therefore, engineers decided to lengthen the ship's body and create enough space at the front of the deck. However, due to the obstruction of the central structure of the ship's body, safe landing still required highly skilled pilots. Any mistake could result in an aircraft falling into the sea. To mitigate this, engineers had to redesign the ship's body, moving the central control room to the right side of the aircraft carrier. But this caused the ship to tilt, so they only filled the left fuel tanks to maintain balance using the weight of the fuel. However, as fuel was consumed, the ship would slowly tilt to the right. Even with the hangar moved to the left, the ship's stability remained low due to various equipment and clutter. After over 20 years of repeated testing, engineers decided to extend the left side of the aircraft carrier and move all heavy equipment to the right. This not only lengthened the runway but also allowed the parking of more than 50 aircraft. However, landing on the carrier at sea required highly skilled pilots, and accidents caused by pilot errors were common. To address this, engineers installed a arresting gear below the deck. It used hydraulic cylinders and pulley devices to suppress the kinetic energy generated during aircraft landings. With takeoff and landing issues resolved, the aircraft carrier's deck became the primary target for enemy bombers. Early decks were made of wooden materials, and if damaged, the carrier would lose most of its combat capability within a short time. To solve this problem, engineers replaced the deck material with armored steel. While this made the carrier impervious to bombs, it caused the carrier to be top-heavy, reducing stability and safety. To compensate, engineers continued to widen the carrier's body and lengthen it to maintain its streamlined shape. However, the massive size of the carrier made it easy to detect. To address this, engineers designed a special long-range radar detection system that scanned the entire sky 24 hours a day. Any approaching threats would be identified, and escort aircraft would be instructed to intercept and eliminate them in the shortest time. Even if enemy aircraft managed to evade detection, the carrier's deck was still protected by heavy anti-aircraft guns, which could accurately destroy any nearby flying objects. Nowadays, with the continuous development of aviation technology, propeller aircraft have been gradually phased out. More advanced jet aircraft can reach speeds of over 200 kilometers per hour. To make stable landings on the deck, pilots must find the right angle of descent, or they risk colliding with other aircraft or the deck itself, resulting in serious accidents. To address this, engineers installed a set of mirrors and lights on the deck and used reflectors to project the lights onto the optimal landing angle. This way, pilots only needed to stay within the range of the lights to achieve a successful landing. However, this method did not account for the impact of waves. When the sea was rough, the signal lights would sway. To solve this, engineers mounted the reflectors on a gyroscope support, ensuring that pilots could find the correct landing path regardless of how large the waves were. When all these complex problems were solved, endurance became the biggest challenge. Due to the enormous size of the aircraft carrier, when it sailed at full speed on the sea surface, its diesel fuel would be depleted in just 3 days. To address this, engineers installed 8 nuclear reactors inside the ship. By using nuclear fission to release huge amounts of energy, they heated water to produce steam, which was then delivered to turbine generators through pipes. This allowed the turbine generators to rotate and provide endless power to drive the propellers, enabling the carrier to sail for 20 years without refueling. Finally, a modern aircraft carrier was born.